Okay, remember, lesson 18 is on writing, evaluating, and finding equivalent expressions using rational numbers. And that's what we're going to be doing now. We're going to be writing some expressions and then working with equivalent ones. Okay, so exercise 2 here says, 3 friends went to the movies. Each person purchased a medium-sized popcorn for P dollars, so P represents the number of dollars for popcorn, and a small soft drink for S dollars, so S represents the cost of a soft drink. Write an expression that represents the total amount of money in dollars that the 3 friends spent at the concession stand. Not what I wanted to do. Hold on. Hold on again. This is what happens when you mess with I want to delete it. Delete. There we go. Sorry. Okay, let's try this again. The reason I'm trying to put a line is because we're going to go with 2 different expressions, 2 different equivalent expressions. So one way to think of this is to say, you know what? I'm one of the friends. I am buying popcorn and a soft drink. That's how much they cost. Okay? That's how much it's going to cost one person, but we have 3 people doing it. So kind of think of like the tape diagrams, right? If you did a big tape diagram, which is why I had those boxes up there, each person is getting a popcorn and a soft drink. And how many people are doing that? 3. That's where this comes from. Now, you could think of it a different way, though. You could think of it as, well, you know what? How many people are buying popcorn? 3. How many people are buying soft drinks? 3. Except use the right variable. And so if you wanted a total price, you'd add it together, okay? But I want you to realize is if I were to use the distributive property right here, 3 times P plus 3 times S, that's what I would get, okay? So these really are equivalent expressions, even though we write them differently. And some of you might just start with this. You might think, hey, I'm buying 3 popcorns, 3 soft drinks. How much is it total? Some people might be like, one person's buying a popcorn and a soda. There's 3 people doing it. So these are really equivalent. So the concession stand charges $6.50 for a popcorn. Okay, so that means P, because that's the price of popcorn, is $6.50, rational number. $4 for a soft drink. So S equals 4. How much do the 3 friends spend? Well, I told you they were equivalent. Do you believe me? So in this case, I'm going to go 3 times $6.50 for P plus 4 for S. Following order of operations, we do what's in parentheses first. $6.50 plus 4 is $10.50. And if I go 3 times that, oh, I can even show you on a calculator. $31.5, which is $31.50. Now, if you do this other expression here, you're going to go 3 times P, which is $6.50, plus 3 times S, which is $4. That's a 3 there. 3 times $6.50 is $19.50. Plus 3 times 4, which is $12. $19.50 plus 12 is $31.50. So you can see how they're equivalent expressions and how we get the same answer for them. So it doesn't matter, okay? Now something else you're going to have to do in your homework. It's not necessarily going to be a real life problem. It's going to be prove like we did here, but not in a real life problem, okay? So it says complete the table below by writing equivalent expressions to the given expression and evaluating expression with the given values. And I believe I put like the actual directions inside the box. Okay, so don't stress, just follow along here. It says evaluate when y equals 1. So it gives us this right here, 5 times the quantity, so in parentheses 3 minus 4y. So if I wanted to evaluate when y equals 1, I'm going to input it for y. So I'm going to go 5 times 3 minus 4 times 1. Order of operations, say to simplify inside the parentheses. Order of operations, say I got to do multiplying before subtracting, so that just ends up being 3 minus 4. Well, 3 minus 4 is -1, and 5 times a -1 is -5. And I wrote down every single step there, okay? But just understand that's what's going on. Now this one here, I believe in your homework I wrote write an equivalent expression. So I want to write something equivalent to this one right here. Well, since there's a number outside of this expression in parentheses, I could just use the distributive property. 5 times 3 is 15. There's a minus sign there, so I'll put a minus sign here. 5 times 4y is 20y. And then once I do that, then I want to evaluate for when y equals 1. Okay, so just again, follow the directions I give you in the box in the homework. So I'm going to go 15 minus 20 times 1. Order of operations say to do multiplying first. So 15 minus 20, and guess what 15 minus 20 is? -5. Okay. Now there are other equivalent expressions we could write, and I'll just give you a quick example. But I don't think you're gonna be asked to do more than one. See this like 20y here? I could break that up into, let's say I did this. Keep, change, make it plus a -20y. I could break it plus -10y plus -10y. Okay, and again, don't stress about this part. I just want to show you there's lots of different equivalent expressions. I could make it -20 here and break it into -10 plus -10 because it equals -20. Now, if I wanted to evaluate when y equals 1, I could. 15 plus -10 times 1 plus -10 times 1. Well, -10 times 1 is just -10, and -10 times 1 is just -10. And just following order of operations, 15 plus a -10 would be 5 plus a -10. Well, 5 plus -10, still -5. Okay, so basically what I want you to take away is as long as you write an equivalent equation following the rules and skills that we've been practicing, you can't change a problem, but you can write something that equals it. You're going to get the same solution as long as you're putting in the same number. Okay, so that's going to come in handy later on. We need to manipulate some expressions to make solving easier.